Hello and welcome to today's DSpace Innovation Coffee Break. My name is Peter Ngure and today we are discussing about taking your ROS projects to the next level. ROS 2 has been used by software developers to develop beautiful prototypes, whether it's in the agriculture domain where automation is taking center stage, or in the efforts to roll out autonomous shuttle buses. The number of prototypes developed using ROS 2 continues to grow. Still, despite the growth in the number of prototypes, there still are some challenges faced when we try to go into productive environments. Some of the challenges faced by ROS 2 users include real-time behavior. ROS 2 is not real-time capable. Challenges with inefficient allocation of resources, complicated communication, and scheduling overheads lead to performance variability, which means ROS cannot meet strict timing requirements. As fast as possible data replay is important when you're doing your validation for perception algorithms and components, and manipulating ROS 2 reading policies to achieve this is difficult and error-prone. There's also time synchronization in cases of data fusion. If the upstream nodes have varying latencies, we face major challenges when we're trying to attain time synchronization in the downstream sensor fusion nodes. Zero copy mechanism is for time-critical system require efficient management of resources and data exchange between nodes. This introduces undesirable latencies. Resolving this when you're using ROS 2 requires manipulation of low-level techniques in memory management, which again introduces errors into your project. Last but not least, there's data format agnosticism. In addition, data format agnostic behavior is desirable in a world where we receive huge data sets that are packaged in different data formats. When you use ROS 2 together with Artimaps, you're able to solve most of these challenges or introduce real-time capabilities, easy synchronization mechanism, a zero copy approach, and then it is you bring compatibility with RTOS such as QNX and real-time capabilities. There are also reading policies that can be easily adapted so that you're able to achieve as fast as possible data replay. Now with the interoperability of Artimaps with ROS 2, you can bring ROS 2 prototypes and projects to the next level. And let's see this in a simple short demo. So here we are on the Artimaps Studio. That is what you can see on the screen. And on the left-hand side, you have the registered components in Artimaps. And down there, the Explorer, where you can see all the registered or the components that you have developed and the ones that are shipped with Artimaps. Our interest today is on a ROS, is to implement some ROS nodes inside Artimaps. And you can see down here, you have ROS 2 Humble and ROS 2 Ion. But our interest today will be on ROS 2 Humble. So we register, this is the normal process in Artimaps. We register this node. And as you can see, there are different things that you can do with the package. You can get the ROS 2 node manager where you can run ROS 2 nodes inside this component, or you can get ROS 2 ROSbag importer to be able to read the different data types from ROS, or your normal topic subscriber and publisher. I would like to do some manipulation or change some properties of the component. Now we have the perception algorithm here from ROS. So a perception algorithm is running inside a ROS node in Artimaps. And we want to feed this algorithm with some data. We want to give it some data. And as I spoke at the top of the presentation, we can have data agnostic. So you might be interested in working with pickup data sets. If you're interested in pickup, then you have a pickup package that you can use. So register the package and you can be able to get a pickup player and play your pickup data sets. Maybe your interest would be MDF4, or the data set that you have is in MDF4 format. In this case, you would get the MDF4 package, register the package, and you can be able to drag and drop the importer. But in this particular demo, we are more interested in pickup data because the data set we have is in MCAP format. So we have a package for the MCAP format. I will drag and drop it here. And we have the MCAP importer. I'm going to delete the other data components. So I can load my data into the MCAP importer. Here I have my data set from Kitty. And now the component is loaded up with the data. But this data is not consumable by our perception algorithm. We would need to do some manipulations of the data, or we would need to do some data pre-processing. Again, we have some tools for this offered to us by Artimaps. So we have the JPEG decompressor to decompress our frames. You can connect this to the output of the camera data. And then we have an OpenCV package for computer vision applications. Here. And we can get some resize because our perception algorithm accepts our images or expects our images in a certain size. So we are going to do a resizing of this. Yeah, our size, you can manipulate the size here. So in this case, this is the size that is expected by our algorithm. And we can feed this data now to our algorithm. And to get some of the objects, we would like here to use some Python code. So let's go to a Python code, a drag and drop again. I can just drop my code here and it's going to be detected. And I can get the output of my ROS node so that I get the objects out. Now I want to fuse these two streams together. So the stream of my initial data set together with the output of my perception algorithm. And here we'll use an overlay from OpenCV. And we can connect the two to get data fusion. So now we have our image being overlaid with our bounding boxes. For visualization, we can go to the viewers and get a viewer relevant to our data. So here it's an image viewer. And now we can run and see what we get from this. And now you will see the bounding boxes, but there are few bounding boxes and they are highly delayed. So they're not detecting, or you cannot understand what the object is or the algorithm is trying to detect. And the reason is, so for the few bounding boxes, we can make a few changes here on our algorithm, and this would be decreasing our confidence level, maybe to a 0.4. If we did this, we should expect more bounding boxes to appear. So there are more bounding boxes now visible, but again, there's still a problem with data fusion. Now, if I was just using ROS, this would be a complicated problem for me to solve, but we are on Artimaps together with ROS. Let's see how we can do this. So I'd come here and change the reading policy to use Artimaps timestamps. And then for my fusion component, I would just say let it be synchronized. So the reading policy would be synchronized. And my expectation would be now my frames are going to be synchronized by just clicking a few buttons. Now, as you can see, the images are quite synchronized. So you can see what objects are being detected by the algorithm, the vehicles and the pedestrians or a bicycle on the side. But what if we wanted to do a data replay, as fast as possible data replay, as we said initially? How can we do this? It would be easy. We just need to change our reading policies. So let's allow our data to be released immediately, but then manipulate our reading policies. Currently we have FIFO reading policy, but we can change this to never skipping. To never skipping. And now we can play and see as fast as possible data replay. There you can see it's as fast as possible data replay with the synchronization again being managed by our data fusion component. And we're able to showcase that you can be able to solve most of the challenges that you're facing in your ROS projects when you combine these with RTMaps. So to recap, RTMaps brings to your ROS2 project real-time capabilities, easy time synchronization, a zero-copy mechanism, as fast as possible data replay, and of course, an agnostic way of handling data formats and standards. Would you like to have more details about how we can bring your ROS projects to the next level? Please visit us on our website and contact us. Thank you.
DSpace, your partner in simulation and validation.